10 quintillion years from now, the sky goes silent. Not just quiet, but fundamentally empty. The familiar glow of galaxies has vanished. The cosmic symphony has faded to a single, sustained note of near-nothingness. What survives when time itself seems to turn to dust? When the very concept of a year has lost its anchor to stars and suns? Tonight, we are not just stargazing. We are time-traveling. We will leap past the entire history of civilization, past the death of our sun, and into the universe's far, far end, to glimpse what remains. It is a journey into the ultimate cold and dark. Ready? Look up. First, you leave our era, the stelliferous age, the age of stars. You watch as galaxies recede, carried away by the relentless, accelerating expansion of space. The Andromeda Galaxy, once on a collision course with our own, is now a faint smudge, racing away from us faster than light can bridge the gap. The night sky thins. Familiar constellations warp into unrecognizable shapes before their stars fade entirely. Space itself stretches, pulling the great cosmic web apart. Islands of gravity, our local group, then the Virgo supercluster, become isolated, drifting dimmer and farther from one another with each passing moment. Star birth, the engine of cosmic light, slows to a crawl, then wanes completely. The universe runs out of the free gas needed to forge new suns. The Milky Way, once a vibrant spiral of creation, ages into a quiet, solemn city of exhausted, dying lights. The degenerate era begins. The last red dwarfs, the longest living stars, finally exhaust their fuel and flicker out. Bright shining stars are now a distant memory. What remains are the universe's embers, the stellar dead. There are white dwarfs, the collapsed cores of sun-like stars, slowly cooling to blackness over trillions of years. There are brown dwarfs, the failed stars that never quite ignited, radiating a faint, deep red glow. And there are neutron stars, the impossibly dense, silent, collapsed hearts of massive stars. Planetary systems, no longer held by the steady gravity of a living star, begin to unravel. Gravitational tugs of war between these stellar remnants eject their worlds. Countless planets are kicked free, becoming frozen rogues that wander the interstellar darkness without a sunrise, their skies a permanent, starless midnight. On galactic scales, the drama slows to a profound hush. The grand, violent collisions of galaxies are a thing of the distant past. Orbits have decayed and wandered. The galaxy is a ghost of its former self. Now and then, a faint, fleeting flare, a whisper of activity. Perhaps a brown dwarf is torn apart by a white dwarf, or a stray cloud of gas brushes against the neutron star, creating a rare, final accretion spark. But these events are extraordinarily rare, separated by eons of silence. Most of the time, there is only the cold, dark architecture of gravity and the quiet, patient mathematics of orbital mechanics. Black holes rule this era. They are the new centers of gravity, the undisputed masters of the cosmos. At their event horizons, space itself becomes a one-way river, flowing inexorably inward. Cross that boundary, and you vanish from the story of the outer universe forever. Supermassive black holes like Sagittarius A at our own galaxy's core sit in ancient silence, quietly feeding on the slow, steady rain of stray stars, planets, and cold gas that wander too close. Their own end, through the theoretical process of Hawking radiation, is an almost unimaginable distance away. For a black hole the mass of our sun, it would take 10 to the power of 67 years to evaporate. For the supermassive ones, it's a timescale that makes quintillions of years feel like a heartbeat. For now, they are patient, eternal monarchs in a fading, skeletal empire. But what about matter itself? The very stuff you, the planets, and the stars are made of. Some theories of particle physics predict that protons, the building blocks of atomic nuclei, are not truly stable. They may decay over vast timescales, far longer than the current age of the universe. This remains unconfirmed, a frontier of modern science. But if proton decay happens, then all ordinary matter would slowly, particle by particle, dissolve into a sea of low-energy radiation. The great stellar remnants, the white dwarfs and neutron stars, would simply evaporate. If not, they linger, cold, stable, and mostly inert. Either way, the background of the universe becomes a thin, featureless soup. Relic photons from the Big Bang stretched to wavelengths longer than galaxies, and a sea of neutrinos passing through everything like ghosts. Energy gradients fade. The cosmos coasts toward a state of maximum entropy, a final, uniform equilibrium. Yet even in this near-total darkness, a few exotic possibilities glimmer. The white dwarfs that remain, should protons not decay, will continue to cool. After quadrillions of years, their immense pressure and cooling temperatures will cause the carbon and oxygen within them to crystallize, much like how carbon on Earth forms diamonds. The universe will be sparsely dotted with black dwarfs, planet-sized diamonds, cold and dark, but perfect and eternal. A final, beautiful form of matter. And on even longer timescales, there is the bizarre, mind-bending possibility of random quantum fluctuations. In an eternity of chaos, could particles randomly assemble into a thinking mind, a Boltzmann brain, for just a fleeting moment, before dissolving back into the void? It is a philosophical vertigo at the edge of physics. You stand, if stand is even the word, on a rogue world beneath a sky that is almost perfectly black. There is no sunrise, no moon, no Milky Way. The concept of a sky is just the absence of everything else. Perhaps if you are lucky, a single distant black dwarf, a diamond star, catches a stray particle and offers a momentary glint. But mostly, nothing answers. 10 quintillion years is less a measure of time than a feeling. It is solitude stretched to the absolute horizon of meaning. It is a universe where almost nothing happens, and it will continue to happen for an eternity. And yet, this desolate journey into the deep future turns you back with startling clarity to now, to this brief, brilliant age when the universe dazzles with light, when warmth and energy are plentiful, when stars are being born, when galaxies are colliding, and when we can gather, look up, and ask these questions together. Hold this moment, feel the warmth on your skin, look at the light filling the room. It will not last forever, but that is precisely what makes it, and us, so precious.